In this video, with this question, let's build a conceptual framework for understanding the different types of solutions a system of linear equations in two variables will have. Let's get started. For what value of k will the pair of linear equations 3x plus 4y equals 12 and kx plus 12y equals 30 not have a unique solution? How are we going to approach this? Let's start building the framework by understanding when will they have a unique solution. From there, let's deduce when will it not have a unique solution and then arrive at the answer. When will they have a unique solution? What do these linear equations ax plus by plus c equals 0, dx plus ey plus g equals 0, what do they represent? When you plot it on a graph sheet on an xy plane, each of these equations is going to represent a straight line. So this is one straight line, this is another straight line. The solution to the system of linear equations essentially tells us a point on each of these lines. So solution, if the values of x and y satisfy both these equations, then it represents a point on the first line and it also represents a point on the second line. If it's a point on the first line and a point on the second line, then obviously it's a point common to these two lines, which means it's a point of intersection of these two lines. So the solution to a system of linear equations in two variables is nothing but the point of intersection of these two straight lines. At how many points will they intersect? The obvious thing that comes to our mind is they intersect at one point. Brilliant. They intersect at one point provided they are not one of these two. The first one is if these two lines ended up being parallel lines. Parallel lines obviously do not meet. Then they do not intersect. If it is not this, then they will intersect at one point. There's one more case. If these two lines are not coincident lines, right? The line and second line is on top of it. So if these two are coincident lines, then it's not one point where they'll meet. They'll meet actually at infinite points. So if it is neither this scenario nor this scenario, then they're going to be intersecting at one point. So what happens when they are parallel? Their slopes are equal. What happens when they are coincident? Their slopes are equal. So if these two straight lines will have to intersect at one point and have a unique solution, then their slopes should be different. So when will they have a unique solution? The lines representing these two equations will have a unique solution, will meet at one point if their slopes are different. So how do we come to that? Where do we get that? What factor or like what condition will make that happen? Let's find out the standardized form of writing these two equations. The standardized form of writing a linear equation or the equation of a straight line is y is equal to mx plus c, where m is the slope and c is the y-intercept of this line. Let's rewrite this ax plus by equals c, this and dx plus ey plus g equals 0 in the standardized form. So we get it as y equals minus a by bx minus c by a. The second one, y equals minus d by ex minus g by e. So if it's y equals mx plus c format, the slope of the first line is minus a by b. The slope of the second line is minus d by e. We realize that they'll have a unique solution when their slopes are different, which essentially means minus a by b should not be equal to minus d by e. Let's rewrite it as cancel the negative signs. A by d, taking the d to the denominator and b to the numerator. A by d should not be equal to b by e for these two straight lines to have a unique solution or these two equations to have a unique solution. Now, we know that this is the condition for a unique solution. So to not have a unique solution, the condition is exactly the opposite, which means their slopes should be the same. Whether they are parallel or they are coincident, their slopes are going to be same. In which case, here we'll have a scenario where there is no solution. Here we'll have infinite solution. In either case, we are having a scenario where we do not have a unique solution. So the condition for not having a unique solution is a by d equals b by e. In this question, we'll have to find out that value of k for which it will not have a unique solution. What is a? A is 3. What is d? D equals k. So a by d, we'll write it as 3 by k equals b by e. B is equal to 4 and e is equal to 12. So value of k, take it to this, let's cross multiply. K equals 3 times 12 upon 4, 36 upon 4, k equals 9. The value of k equals 9, then we'll end up having these two lines having the same slope. These two lines have the same slope, then they're not going to have a unique solution. Let's complete till that part in a printed form. Trying to solve for k, a by d equals b by e, so we get the value of k to be equal to 9. When k equals 9, we know it does not have a unique solution. We also know when it does not have a unique solution, there are two possibilities. It could be parallel or it could be coincident. In this case, we are talking about infinite solution. In this case, we are talking about no solution. What will be the case here? Which is not needed to solve this question, but let's understand what will be the case here. Parallel lines have the same slope and two different y-intercepts. If C represents their y-intercept, it's C1 and C2 for parallel lines. If it is coincident lines, their y-intercepts will be the same. So C1 will be equal to C2. Let's check out what happens in this case. We have a 3 by 9, we'll write it because we have found the value of k to be equal to 9, equals 4 by 12. So this is a 1 by 3, this is also a 1 by 3. If C1 by C2, or if this, whatever the last terms, A, B, C by F, if this is equal to a 1 by 3, then we are talking about these two lines being coincident lines because these two lines have the same slope and the y-intercept is also same. If it is not equal, then we are talking about different y-intercepts. 1 by 3, 1 by 3. Had it been a 1 by 3, the denominator should have been a 36, which is not the case here. So what we are talking about in this case, when we are saying that it does not have a unique solution, in this particular example, we are talking about these two lines representing a pair of parallel lines. So they'll have no solution. Choice A is the answer. What is the value of k? The value of k equals 9. Before you leave, sign up at wzko.in/core. Take up a trial user ID. Go through this topic, statistics and average. It's comprehensive. You'll understand the teaching methodology, get comfortable with it, get comfortable with the UI, UX. You can use it on an Android phone through an Android app, which is available on our website or on our website, right? And it seamlessly syncs between one and the other. So you can start a topic at home on your desktop or laptop, and on the way to work, you can complete it on your mobile phone. Having done the first topic, convert it into a paid user by signing up and paying for it. And lastly, before you leave, subscribe to this channel, youtube.com/Vizako. Best wishes for your GMAT preparation.